Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. Welcome to our podcast. In this episode, we uncover how a physicist's remarkable mini-universe experiment suggests that time may not exist the way we have always believed. It all began with an unusual experiment in the lab. A physicist saw time emerge entirely from an isolated system, a mini-universe he created. Giovanni Barontini detailed his experiment in a study published June 11th in the journal Physical Review Research. He aimed to answer the age-old question of where time comes from. Some theories suggest that the universe as a whole is static and time shouldn't exist at all. Nothing on the outside is affecting it, so how do we experience time? The experimental physicist at the University of Birmingham set out to understand this problem of time. He tested the idea that time isn't an ingredient of reality, but is the result of how different things inside the universe interact with each other. To test how time could naturally appear without an outside clock, Barontini created his own mini-universe in the lab. He used a Bose-Einstein condensate, a unique state of matter that only forms near absolute zero. In these extremely cold conditions, thousands of individual atoms slowed down to a near standstill and behaved as a single quantum superparticle. To create the mini-universe, the physicist placed the condensate in a trap. He divided it down the middle with a thin sheet of laser light and observed only one half, which he called the bright sector. Barontini ignored the other part, deliberately deciding not to see it. He noticed that the atoms naturally flowed back and forth across the barrier and occasionally spilt over the barrier. He called the moment they flooded the bright region the Big Bang and the Big Crunch, when they flowed back out. Instead of using any external laboratory clocks to track the experiment, Barontini wanted to see whether the mini-universe could keep track of its own time. He built an entropic time, a clock that measures the disorder or randomness in a system. In this case, it was defined by how much entropy was flowing between the two halves of the system. By tracking this internal change, the physicists could perfectly order the sequence of events without an outside clock. Barontini even saw time speed up, slow down, and stop completely. When atoms were moving rapidly across the barrier, time sped up. When the flow slowed down, time slowed down. If the atoms stopped moving and became completely still, time effectively stopped. Time was speeding up or slowing down, or even stopping, depending on what the system was doing, Barontini told Live Science. He also found that both time itself and its one-way forward direction might stem from the same source, an observer choosing to ignore information. When he deliberately chose not to look at the dark region, Barontini gave up knowledge about that half of the system. This ignorance, measured as entropy, is precisely what created the flow of time in the observable half. The experiment is the first to successfully generate and control a sense of time entirely from inside an isolated system. It proves that time is not necessarily a hard-coded rule of the cosmos. It is an illusion that emerges from the internal interactions and changing disorder of matter. Thanks for tuning into this incredible story.